Now it's recording. Thanks.
Thanks. Welcome everybody to the Trojan Poke talk. It's about embedding libpoke actually into your own program. In this talk, I will go through introduction to libpoke, then how to embed libpoke in your application. We will see some real-world examples, like I have written a simple Poke Init program, which captures network packets and give them to Poke as an IO space. And importantly, the GDB integration of Poke inside the GDB. And we will talk about some tips and best known practices of using libpoke and current limitations and future work. Okay, so again, what is GNU Poke? It consists of two parts, one libpoke and one poke. The poke is the program, the CLI. We will have soon more than poke. We will have poke-D and other stuff too, but currently it's like this. And libpoke is, it provides us the incremental compiler for Poke programming language, the PVM, Poke virtual machine, which compiler generates code for this PVM, and the PVM will run the actual code, and the IO space, which is the place that things happen, the actual poking and picking. So, what is a Poke programming language? It's a procedural programming. It's statically typed. This is unusual for interactive programs, but I like the statically typed because it catches a lot of errors too early, and this is awesome. It is interpreted, as I told you, it uses jitter, and it's interactive. The language designed in a way that enables you to be relaxed and easy in using it. It's interactive. You can declare anything, types, functions, variables, and it's okay, and it works as expected. And it was specifically designed to be useful, suitable for describing and poking binary formats. And a small thing about PVM, because PVM is not exposed to the user, we will not talk a lot about just small facts. It's a jitter-generated virtual machine, and it's a stack machine. The only part of PVM which is actually exposed to the user is the PVM values. So you see this nice ASCII art slide. I stole part of it from Jose. So here you see, let me use the cursor. Yes, here you see the compiler part, which generates code for the PVM. And the PVM will interact with this IO space, which consists of many devices, like 0 device, NBD, which is a network block device. It supports streams like std-in, std-out, and process device, which you can attach to other processes and poke their memory. And it has a memory device, which is something temporary in the libpoke memory, in your process memory, and you can do stuff like copying, serializing this. It's a very nice and useful and cheap device to have. And then we have a foreign device, because we cannot support every possible devices. So we enable the user to do what they want to do. So it's very nice. So, and you see, for each part of these components, we have an opaque data type in the libpoke API. For the compiler, we have PK compiler. For PVM, we have PK val. PVM is not exposed to the user. Basically the same thing, but the name is actually wrong here. And PK IOS, which is handled to the IO space. So these are the types we are going to deal with. So let's have some fun on the slides and write some code. Here we start from an empty program. It's a legit C program. So we can to use libpoke, you have to include the libpoke.h. That's for sure. So we have, this is the initialization here. We need this structure to be defined. I talked about it. You give it the pointer to this PK compiler new. You will get a handle to this new instance of compiler, and you can free it. Currently, due to some small problems, global variables, you cannot have more than one compiler instance in the program, but it will be fixed for sure in Poke 3. So what is this term if? It's a structure, obviously, consists of function pointers for terminal output interface. The Poke compiler wants to tell something, like there is a syntax error, or the user writes on the program that prints some stuff on the on the output. All of those things will be given to us using the function pointers we provide with the terminal interface, actually. And the previous code is not completely correct because we didn't have the error handling, so I added the error handling. So this is basically initializes and then free the compiler. And this is the actual structure for PK term if. So from the out, we have something to flush if Poke wants to tell us that, hey, flush the string. We call this function pointer. Put s is like put normal put s, but will not add a new line, which is the right thing. We have a printf. We have indents. We want to ask user, okay, I need this level of indentation, and each indentation needs to be, for example, a step, white space 2, 4 space for each level. And this is a nice feature that you can easily. This is part of the problem I was talking about. It's we can have just only one instance of this problem because we don't have data. I had sent some patch, but we didn't. We had some discussions, and it didn't make it for Poke 2. But yes, for sure, we have to make it like your jitter interface, which is complicated, but right and correct. It's more better. Yes, and here the class function and end class with this Poke will tell you what's the class of this output. For example, it will tell you that, okay, here the integer starts, here the integer finishes, here the offset starts, here the offset finishes, and so on. This is useful for example in terminal when you want to have different colors for the things, and actually the magic behind making the colors is leave text style, which uses which actually Poke use this functionality. And we have hyperlinks, which I will not talk about them in this talk, but they are nice things, terminal specific. And these things color, which is not interesting to me. So I have to tell you that when you actually create an instance of a compiler, you are already loaded two Poke files. The first one is the pickle RT1, which is essential. This is the part of implementation of libpoke. You cannot just remove it or change it. It is part of the thing because and the trend in Poke is like this. If you can express things in Poke itself, do it in Poke and don't go to the macro assembler or we want to lessen the pressure on the code generation and put the stuff in the language. So that's it. It's exceptions are there, the definition of exceptions. The assertion is there, and a lot of things I will show you. And this istid.pk, it has some standard things like standard types. For example, int, long. These are not poke built-ins. These are type definitions. So actually, int is int bracket 32 or angle bracket 32, and long is int angle bracket 64, and so on. So at this point, we have these two functions. Sometimes you don't want, for example, in GDB integration, we don't need int and long definitions. So there is also another PK compiler new with flags function that you can tell, okay, don't load part of this DB. So this is the problem. We have a poke program here, and we want to give it to the compiler, to the poke compiler. So how should we do that? How to fit the compiler, actually? And the assumption here is that we have the poke code as a string or file. No, you have to have it. And then what I call the most useful functions are interface to the compiler and the PVM. All of these functions called PK compile, but they are not just compiling. They compile and execute the code. The first one reads code from the file name, and the second one is read from memory. They are text. And these two are specific. If you want to just compile and execute in the statement, you can use this function. If you want for expressions, you can just use this function. And all of them has a return value here. You see pointer to PK val, which is exception. If the code terminated by unhandled exception, so we can report it to the API user. So we have an application in C, and we call it app.c, and we already did some early stuff. Now we want to move and look at the app.pk. One where we are using poke as an extension language somehow. For example, if you work all languages, for example, a game can have for example, they have Lua files that you can set some parameters in them, and the game will be changed behavior based on those things, or in Guile or any other extension languages. Here is the same. In this application, we are defining some int setting, which is 0, some string setting, which is no, and we have a function which returns void and takes no argument to do something. And now we are in the main function, so we want to compile and run this file. So we call pk compile file. We give the compiler instance to it, and the name of the file, which is I assume that is in current directory, and the exception. So this code is just basically but it doesn't have error handling. So here I'm adding error handling, but we have two kinds of error handling. One is compilation error. For example, you have syntax error in the app.pk, or any kind of, or for example, using a non-const thing in defining units. These are compile time errors. So the function will return something other than pk okay, and I have to somehow report it to the user that the problem is in is a compile time error. So the next class of problems are exceptions, runtime problems. The code has, for example, raised an unhandled exception. So we have to somehow handle the exception and go to somewhere. I don't care about somewhere, but you want to change the flow of program. Maybe. It's up to you. So at this point, we are successfully loaded app.pk, so which is very great. So this was the initialization part. Every program can have we can imagine it as initialization phase and execution or main loop phase. We do the real stuff. So until this point, it was initialization. We now already have all the stuff I want. Now we want to interact with the incremental compiler to actually do something useful and use libpoke. There are some interaction strategies. One is to put all logic in apt.pk and only call poke functions using pk-call C function. The other one is to generate poke code as a string and use the pk-compile buffer statement or expression files. Both of them are good. You have to choose between them. So I personally like the first. I try to use the first approach as much as possible. Sometimes you don't have any options. You want to create a type at runtime, like in GDB example. So it's not 100% that the first one is good, but I at least personally like to start with the first approach and then fall back to the second approach. I learned this from Jose actually, and so here's an example of the first approach I told you. We have, for example, we have these two variables in apt.pk, and I want to somehow somewhere reset them to their default value. Okay, I define a function and set them to the initial value. So here is the poke, this upper part. Here on the lower part is the apt.c, my C code. So first of all, I have to get a handle to my function, reset A and B, which is I'm using pk-decal val, which asks compiler, hey compiler, give me the reset S and B, and it is a pk val because everything is a pk val. Okay, so then for sure it's not pk null because I know it's there. But this is a good thing. I will show you an example later. That is a good idea. When you load your app.pk, after that, check the declaration of things to make sure that you catch errors early. So, and after that, we call the function pk-call, which as the first argument gets the pk instance of our compiler. The second is the pk-val of the closure or function. Here we don't have return value because it returns what? So we put null there, and we have no arguments, so 0. The same logic, but there is a inconsistency here. You don't see any exception, for example, that yes, we consider it, and maybe we have to somehow report it, but currently this pk code, okay, we'll check for both things. Either maybe you're giving the wrong thing to the poke. All of these cases will, yes, because I admit. Okay, and here is the second is an example of second strategy. We have the same variable but no functions to reset them. So I'm going to use pk compile buffer. And here you see the first argument is the pkc as always, and I'm getting the compiler these two statements. And this is null, non-important, and this is exception. If during the execution something bad happened, it will notice that. So for all things we have to, for compile time errors and here runtime error. If the exception is not pk null, handle it and go to somewhere else. So which approach is better? As I told a little, it depends really. But which approach I explained it. So is the first approach too slow? No, no, definitely not. Because I didn't measure it, to be honest, but this is my intuition. When you're giving something to the PK compile buffer, it will starts from the lexer. It will invoke lexer, parser, all passes and phases in compiler, and then code generation, and then it will go to execute the code. But when you use PK call, you are giving the compile code, the PVM code to it, and tell the PVM, please run this for me, and it will do it. Intuitionally, the first approach should be faster, because we are not going to compile again and again and again. But I didn't measure it, so I have no claims. And with the second approach, when you are actually making strings and you are generating poke code, you have to be careful somewhere. We have these set of keywords in the poke, so you have to be careful if you are creating a variable, or you are going to create a field for struct. If you're generating the code like the GDB example, we have to somehow normalize these things. Be careful. So here I want to show some important things, that we have two different environments. One is the compile time environment, and one is the runtime environment. Imagine this code where a equals 1, a star equal 2. So it multiplies a with 2 and put the result in a. So this is the compile time environment. You have a variable called a, you're referring to it and doing stuff with that. But if you actually compile this code, it will be a code something like this. If this is a PVM assembly, and I told you that PVM is stack-oriented, is stack-based machine. So here we are pushing 1. This 1 is not a real one; it's a PVM 1. You know, if we want to be simple and don't mention to the optimization that there are there, we can think that all of these things are boxed an object, something like a state variant, or in C++ terms, or in terms of C, a structure with the field kind and with a union with all the stuff there. So it's a runtime thing. It's a variant type, actually. So here it contains 1, and we are pushing that into the stack. And we have this instruction regvar, which will register variable in current lexical environments in the PVM. Here we are in the PVM. So imagine the current lexical environment is 0. So this is the first entry, this 1. And after, so these two first instructions is this line, a equals 1. So after the second instruction, the stack is empty because we put it into the lexical environment. So, but for the first instruction, we are going to again push var from this lexical environment the first entry. So put the first entry of current lexical environment on the stack. So the 1 will be the a content of a variable will be, and then push another object on the stack too, and call the mul I, which is multiplication for integers. The 1 and 2 are integers, so the type of a is in 32. So we use mul I, multiplication for all, and the mul I will put the value of multiplication on the top of the stack. So we have 3 items in the stack now. The nib2 will get rid of the second and third item on the stack, so you have only 1 at this point. And here we are going to pop this value of the stack and put it in the Current name is current lexical environment in the first entry. Okay, is it clear or there's a problem? You can ask now. Okay. So, but why am I showing this to you? Because to tell you that here, if you see the PVM code doesn't have no idea about variable names. These are for the compiler, these are for the runtime, and these are different kind of things. They are actually the compiler will do the right thing and put the correct stuff here in the push bar and pop bar, but the PVM has no idea of names and variables. You know, it only knows about PVM values, which are specific to the virtual machine itself. And the compiler job is to convert all this stuff from this literal one to this PVM val one. Okay, and we have this function in libpoke pkill decl p. Is this declaration exist in the compiler? We are checking in compile time environment because we are referring by name. Something like this, pkc a decl kind var. Is this a variable a? Do we have a variable a? We also can check for functions and types too. And process writing something. So let's look more closely at only checks the top level. Yes, it only checks the top level environment. You cannot go, for example, in the functions you have or closures or anything or structures. No, only the top level namespace environment. And here we want to look. At this point, we know that about PVM values, and we already use them actually. So let's dig into it more. So imagine that this function double is inside our app.pk. It takes one argument of type int, which is int32 signed, and returns a long int64 signed. Okay, I'm casting the x to long and then multiplication by 2. Yes, normal function. Now I want to, it's complicated than the previous function because it takes argument and returns argument. Here I'm putting the function is about to see it, and you'll be able to see it. And here is the application in C, and I have defined some macros for error handling, for exception handling. These are, we already seen them, so I'm abstracting them away. So like the last time, we get the double from the environment, from the compiler, tell me the PVM val. Here is the fun starts. We have to create an PVM val for our integer. Because it's signed, we use pk make int. And it needs a value, it's 10. And it needs a size, because it's 32-bit, I need to give it 32. And here I'm defining two more pk vals, like ret and exception. And here you see I'm calling this function. This is the return value. And the number of arguments is 1, and it's x, you see. And after the successful run of this pk call, we get here. And I'm using pk print val to actually print the content on the terminal interface. So I'm putting ret here. And because if the VM enable the pretty printer, it's actual poke code, so it can raise an exception. So we have to check for exception too. If everything works as expected, we will see something like this on terminal, or anything, terminal or any other abstraction, memory or pokelets, anything. And here we are checking for. Actually, I have to swap this code, so the code is wrong, but you get the idea. And for example, PVM values integers. We already see the int, so we have uint also for unsigned integers. These are accessor functions to get the size and the value out of the PK value as normal C integers. And we have these two functions for strings. You can make and you can get the result out of it. Here for the offset, but you can see the libpoke.h. There are a lot. And okay, sometimes you want to actually modify the compile time environment, your top-level namespace compile time environment. And here we have def_var, which declares variables, poke variable with this name, and this PK val value. You see, we are telling the compiler that if I use this variable, and the user after this point can use the variable, and it will get the PK val. And so this is more powerful because you can do maybe sometime, I don't know, you can put everything in the variables. You don't have the luxury of a compiler nagging on you, hey, what are you doing here? So be careful a little. And we can change the declaration value also from the C. So there are more stuff, but you can read the libpoke.h because it's a lot of comments and it's pretty readable. So I'm going to talk about alliance tokens, which is a nice feature. It's a technique, I think, I don't know who invented, but I know that Jose maybe is the inventor, I think so. He has a half-written blog post explaining this technique, but not published yet. I think it's more than a year now. I know about it, at least, but someday he will publish it. So until that time, we have to do some guesswork, So in the lecture, the trick is sometimes you want to give the libpoke something. In the libpoke itself, you want to refer to some tokens that are not. You want to actually the host give you what is the okay. No, the host should give this stuff to us. We don't know. We will see in the GDB integration, actually. So in the lecture, we have these tokens. These are real code. We define the class for letters, digits, this $sign, and colon as a separator. So an alliance token is something that starts with a dollar. It's a letter or digit, followed by column separated names. If the lexer, this is handling the lexer. If lexers find this, it will ask the libpoke. Actually, this is the callback that asks for the callback that user sets. The libpoke user, actually, it's a C code. If it invokes that code, here we are getting that function token handler, and we check for if the coding is that's the name of the technique is enabled, and the callback is not null. Do some useful stuff. This useful stuff is just actually based on the tokens. It will insert ASD. It's truly your coding. You're putting your stuff inside the ASD. If else reject, this is not a valid thing because the coding is not enabled. So
Okay, now it's recording.
Okay. Okay. Alliant tokens. This is a nice technique, actually, by Jose, and it's the way when you have you want to put some stuff, give some stuff to the Poke in the programming language level, and you don't have, and you want the Poke user, the host, tell you what's going on and what is the meaning of this token. No, so we are at the token lecture level. We have these items. Let me. Is everything okay, or I? Okay.
Yes, it's all right.
Okay. And okay, we here is in the lecture. We want to recognize some token at the lecture level, but we want to give the responsibility of the recognizing the actual what is the actual token to the user, to the host program who uses the libpoke. So in the lecture we have these letters for digits. This is the $sign and colon. So a lion token is something that starts with a dollar and followed by letters of digits, and then column separated identifiers. So if the lecture detects something like this, it will check that that it's actually in the lexical cuckolding mode or not. That's the term for this kind of things. And if not, we will reject. We don't know. This is not a valid token in Poke. Otherwise, we will handle it. So the nice thing is that based on what this function, this callback from user tell us, we will insert ASD nodes. We are really injecting stuff into the ASD, so the name makes good sense. And it's a powerful tool. The GDB is a user of this technique because, for example, you want to get address of a variable as a Poke offset. So this is the way to do it. And Jose, I don't have my arrows for the slides, so.
Oh, sorry. You need the presenter again, yeah. There you go.
Okay, thanks. And so in the next slide here, you see that it's you have these currently these four stuff. You can say okay, Poke, this is an identifier, so change it makes an ASD for the identifier, or it's an integer. It will make a ASD node for the integer literal or offset or a string. Let me show actual code. So from this point on, when I'm enabling the sharing screen, Jose, please tell me if somebody asks something in the chat, because I don't.
Sure.
Thanks. So lexical thing. Okay, this is an example. Let me first show you the libpoke API itself. libpoke.h. Here, the user has to fill this structure for us. The kind, it's a variant type, which is one of the four things. And if it's an identifier, put the identifier name here. If it's an integer, give us the magnitude, width, and signess. And the same thing for offset and the string. is the callback type. You see, the callback will get the ID, the stuff after the $, and it can report some error messages to the lexer that, hey, this is wrong, and it will give us a token, a pointer to token. Actually, this is the yes. We can set the callback here. So, and as you have to tell the lexer, okay, you have to start to recognizing the stuff, the lexical, the alien tokens. Here's you just add some 1 to it, and it works. Okay. So let me show. This is code from GDB. It's not in the master, but it will be sometime soon. And here you see.
Sorry, Mohammed. I think that the screen is sort of frozen because it is still showing libpoke.h.
Okay, I will stop, and again, funny stuff is happening. So let me disable my webcam. It will help, I hope.
Okay, we see your screen, your full screen. Yeah.
Do you see the code, poke code?
Yes, but this is libpoke.h.
What the hell is going on? It is poke.c.
Yeah, and you are moving around. Oh, sorry.
So
Yeah. This is poke.c. Yes.
Sorry that I don't use syntax highlighting because I don't like it. But sorry. I tried to enable syntax highlighting, but I couldn't. I don't know how to enable it. So here in GDB, the user can actually write this kind of things in the poke code, and the lexer, when gets here, it will give this to us. So, and we will do something interesting. For example, if the prefix is address column, it means we want to get the address of the variable to the user. So here we are inserting an ampersand to the identifier, from this point on after the column, and this is a function from GDB. And if it is successful, the kind of token is offset because it's a size, it's an address in bytes. The magnitude is address, the bits is 64, it's not signed, and the unit is 8 because it's bytes. Okay, and otherwise it can support other stuff. For example, we can $ and the identifier. It will go and try a bunch of stuff to figure it out. Is it an offset? If it's an offset, for example, you see that you have to do something. If it's an integer, and here when we returns back from this function, from this callback, the lexer will actually insert an ASD node there. The poke parser had no idea, is this from source code or from this user code. That's the beauty of this technique. And the other stuff I want to talk about, because I don't have the slides. I have one note there. How it's still connected? It's somebody gives me a signal.
Yes.
Great. And yes, lexer code. Okay, I want to actually show you the lexer code here. You see, here we are in the pickle-lex.l file in the libpoke directory of the main repo. So, okay, go up here. Yes, here. Yeah, I showed you earlier this things, letter, digits, and stuff. This is here, and no. Here's the code I showed you. No, it's real code. And in the body, here's the if. If it's successful, do something, otherwise reject. This is not valid. So if it's okay, and we call, you see this callback here on this text after the dollar sign, and we can see here, for example, based on what user told us, if it's an identifier, make AST, pickle AST, make identifier. If it's a string, make AST type string, and then make AST type, make a string type, and then make a string. You see, the string literal. Here, we will put the integral literal, make AST integer, and so on. See, this is very nice. Go back to the slides. And let's move on to another interesting area of libpoke, which is IO space. We have several IO devices currently supporting the libpoke. We have file support. You can open some file on your file system, and I'm telling the poke that, okay, I want to read it in the read-only mode. And if the thing starts and ends in asterisk with an, I don't know, what is the name? Star, for example. It will be memory. It's a memory IO space. And if it starts with PID colon / and integer, it's the process subsystem. You will attach to this process with the PID 1, 2, 3, and you can poke the. You can. Okay, I will disable the Poke webcam. Okay, and here. This is the NBD backend, and I think this is the correct use, but I've never used it. I think this, and we have a little more stuff. But and you can do these things in C code too. You can. We call this string as handler. This tells the libpoke to use which one of these things, and here I'm going to you can see the API iOS open, iOS close. You can search by the handler, the string you put to the libpoke by ID. Here you get an ID from the open. You can tell it. It will give you PK iOS. I told you it's the opaque type. And here we can, for example, get the current iOS, set the current iOS, and the size, and there are a lot. You can see the libpoke. So this is great. We support a lot of stuff, but for sure we cannot support all useful IO devices, and it doesn't make any sense to do so. So what's our solution? To use foreign foreign IO devices interface. So like the term if stuff, here you have pkiod if. You have to define a bunch of functions, for example, to this normalize thing tells that is this IO device capable of opening this thing based on the handler. For example, the proc IO space look for the prefix PID colon / for example, and stuff like that, and flush. And you can also, this is one interfaces that we fixed for the poke2, we have data here. So this is not using global variables. We have to do the same thing for the term if in near future. So let me show some real example of this. So enabling again. Let me check this. Yes, it works. You see the screen?
Yes.
Good. This is a, let me start from the beginning. This is a normal C code. I'm using libpcap here to capture network packets and do something interesting or useful to these packets. So we have, for example, Poke Init. I write this Poke data and Poke data and Poke free. It's not important stuff. Here we are in the main. I'm going to. I'm actually. My slides are sort of at the end, so this is not about. Currently, it's not about the foreign IoT. I have 3 examples of this library improving at each level, and the third one we will meet the IoT devices. So consider we want to see an example of real usage of integrating libpoke in an application. In this application, which I call PokeCap, I'm using PCAP library to actually capture the networking. So it's a little dance. Okay. Here I'm getting the PKC. So this is my poke initialization. So this is the term if I showed you. I implemented these functions so I can show you here. For example, flush is f flush is it out, puts is like this, printf is this, indent, which is wrong, you have to print put char, I think this is correct, yes. And we don't care about classes, we don't care about the hyperlinks here, and we don't care about the color stuff. But you have to set all these things to actually make it work. This static is not important, but I decided back then to use this. And here you see, I'm going to create a new instance of compiler, and I have a macro to do the error handling for me. And here I'm using the some of our approaches I told you about it. I'm just using pk compile buffer to do all the stuff here in C. I'm declaring the type statistics. I'm going to actually, what happened? Okay, what happened? Poke Init. Here. Here I want to actually find out the histogram, the distribution of network data. I'm just treating them as raw bytes, and I want to count them. No, this is a very simple thing. And I here declaring your variable, I'm just doing in source. So I'm calling it, this is my exception, which I ignore. You should not do this, ignoring things, but I'm doing for this demo, it's completely okay. And pk buffer, I'm defining here the hist reset, which will reset this variable to 0. And here I have a function hist update to actually go through the data and adds one entry to the correct index. So for every new network packet, I have to call this function. and in the beginning, and if I want it, I don't know, I can call reset function. Okay, so this is the Poke Init, PKC Poke Init. Is everything clear? Does anything have any problem or not? Okay, great. So here is our main loop. Here you see here that I'm using pcat next, using and getting this structure out of it and the data. And I call poke data and go to end, and here we okay, it's so if something bad is happening while processing data, go to end. Otherwise, here we go to the beginning of the for loop. Here again, we will read the next one. So let's go to the poke data and see what's going on there. So here I'm using somehow the simplest or the stupid way to do the analysis. I'm passing data by making an array. Here is a good example of how to create a here I'm using some kind of optimization because the array type is always array of bytes. So for the first time, if it actually, okay, I'm initializing it with pk null. And if it's pk null, I want to, I need a size for the element type of the array. So I want 8 because it's a array of bytes which are 8 bits in width. So I'm creating integral type of size this and unsigned, and I'm creating an array with no bound. It's essentially this array, byte this. And for sure at this point it should be here I put stuff. It should be non-pk null. So I'm creating an array with that amount of data and array type, and I'm just inserting data to this array. And here I'm calling this hist update array and passing this array which we just already, and there is no free, it's garbage collected. We have a garbage collector that doesn't work, but it's not our fault, it's GC fault. Okay, we're safe. So let's run this 0, 1. Okay, here I'm not using makefile to show you how it is it is to compile this stuff. We just lpoke and lpcat, and here I don't want to use my actual device because maybe something bad happens. I'm using a data file. I'm feeding the data file. Here is a pcap file captured before by, I think this is an example from, I downloaded from the Wireshark, and you see it will take a while to actually do some stuff. At the end, it will write this histogram, this statistics variable which I have. Let me show you where I put really in the print. Here you see the end label at the end of the program. We call print val with params. So I'm going to use this variable stats data and do a little bit of dance to, for example, limit the amount of elements from arrays to be written to the terminal, things like that, and then finish. You see, it does the job. It's a simple code. Everything is in C itself. Is there any questions I can answer? Let me check my connection. It's okay. So next, okay. Next, let's go to the next version. In the next version, if you go to the Poke Init I'm actually, you see here, this code is simpler. So I'm putting stuff in a file, user-defined file, okay, and I compile it. If it says some kind of compile time problem, fail. If it does some unhandled exception, fail. And here I told you I am expecting in my program to have to use from user to define three things: a PokeCap setor as a constructor. This function will be called in the beginning, and PokeCap run. It will invoke this function for every new packet, for each new packet, and this is detour, which is the thing that will be run at the end. So you see, I'm offloading stuff to the some external poke code. And the other logic is the same, just opening it. So here, let's go to the pokecap.pk. I have here the Ethernet pickle, IP pickle. These are not. You can find them in pokology.org, but it's not in the main repo because it needs some work. I have to write tests and stuff like that. Here I'm defining a more sophisticated, for example, statistics structure to count the packets, count the IP version for packets, and a histogram for all bytes. And here I'm using a memory ISpace. Here my setor is empty. My detour here, I'm setting the base of the VM to 10 and enabling tree mode. And here we will print out the stats on the terminal. So here is the PokeCap run. The libpoke, actually the PokeCap will this file actually here to pcap.c, it will run this stuff and give us the bytes. So I'm increasing the thing here, and I'm doing the histogram. I'm changing the VM to the base 16 and enabling mode 3. I don't know why I'm doing this, because of this prints. It's not useful now, but sometimes I'm using here. Yes. And okay, and I'm first of all I'm copying this stuff, the data that given to me by the user. I'm putting in a memory ISpace. I know here in the beginning, here I defined it. See, and I'm putting all the data there, data lengths and stuff, and then I'm trying to mapping the header, Ethernet header at this offset, which is 0. And if the ether type is not IP version 4, just return. Otherwise, we increase the offset. So we have a IP version 4 packet now, and we are going to map IP version 4 packet at this offset. So you see, and here I'm printing some stuff from source, bytes of source, bytes of destination. I can show you the 0 to here. You see, same thing. Just I'm giving it the pokecap.pk. And you see a lot of things. It's Ethernet header, destination, things like that. And at the end, you will have this. This is the IP, and this is the statics. The setor, PokeCap setor. So I think I'm at the end of my time. But what can I do? Can I continue, or I have to stop?
I think it's okay if you go on.
Mm-hmm. If too late for people, they can let me know. But I am enjoying, Okay, nothing in the chat. Okay. So the next version, which is the most sophisticated version, is about here we are in the Poke Init again, but and the same dance goes on. Here I have one more thing to do. Register my IO device. Here I'm not making an array. You see, here I was in the second version here. I make array. I'm actually here in a stupid loop. I'm making an array and putting stuff in the inserting stuff in the elements. It's you see one time libpoke pcap copy data. This time I'm copying data, and in the poke cap the here the poke code, it's also copying data into the memory item. It's completely unreasonable approach to copying too much data. So it's a better approach is to use foreign IoT devices, which we will see how are implemented here. So, yes. First and most important thing is the name for the interface. Here we have PokeCap. The normalize function is the purpose is that this IO device. This is a chain together. You know, the poke is this it the first thing that poke when you call the open function in poke, it will first give it to the foreign IO devices because it's the most important thing, and the last one is the file. You know, it goes like this. So here, if the first element of handler and the last element of handler is colon, and we support three types of IO spaces here. You know, one IO space for packets, one IO space for offsets, the offset data, and the packets are just bytes appended together. Offsets tells us where are the boundaries of the packets, and timestamps tells us about the time. You know, it's important. If everything is okay, we have to return a non-null thing. Okay, and if error, we have to say okay. If you see here in PokeCap 2, here, you know, I have an IO space for packets, one for offsets, one for timestamps, and all of them are read-only because it doesn't make any sense to change it. Because somebody's writing and it's not really interesting. If you want to change something, copy it to your own memory IO space. So here, back to the IODs stuff. Here, I'm going to here see the packet open, and we just support the we just support the read-only thing. If it's read-only, okay. Otherwise, this is an invalid flag. And this is some stuff which is not important. I'm here counting how many times each of them are opened, and in the close, I'm keeping track of them. Okay, and to make sure that everything is okay. This is useful for. This is not useful in this program, but this technique may be useful somewhere when you want to actually close an IO space and free some stuff resources. So let me again check the connection. It's okay. Yes.
It's good. Yeah.
Thanks. And here I have the get flags, which always return this because it doesn't make any sense. So the period packet, it expects a count and offset. want from this offset this count of bytes. Give me, please. And this is for debugging, of course. If the offset is it's IODUF, if no error handling stuff, and here I'm it's an implementation detail. I'm pre-allocating memory in chunks in 64 megabytes, and then it's a linked list of each chunk of 64 megabyte. So I first have to, according to the offset, find the useful chunk, which chunk I'm going to read data from. So here, and I'm trying to put all packets in one chunk to make things easy, like this. We find the offset and just mem copy the stuff into the buff. So easy. Period off. What was that? Oh, this is packet. Oh, we have 3 I/O devices. This is for packets. This is for offset I/O devices, which contains the 64-bit integers, not integers, offsets actually, of the boundaries of the functions. So this is for the same thing. This is a simple array actually. So g.offset, all of my globals are in the G. So this is it. And for timestamps, it's like the offset one. It's just another array. And here in the real implementation, I based on the IOD, which I in the open return, I decide that to call which functions. And assertion, we don't have any write, so this is fairly great implementation. Error, and this is the size. And if it's from packets off end, the how many elements we have. If it's offsets, do this, and for sure here should be the timestamps. And the flush does nothing. So you see, I think the other stuff here is not something interesting. Just maybe this is good too. This is the append part. I'm just appending to the chunk I told you. Okay, so here I'm again defining some variable, opening my ISpace. Okay, this is a helper function for me, packet. What it goes to the offset IO space, and for example, I can say the index of the packet which I want first, second. It's to start from 0, and it calculates the map and find the for example the boundaries, and give me a mapping and the packet IO space at that offset we calculated here. No, easy. And we have the same logic, CTOR, DTOR, and the DTOR we just show the stats. And here is I changed the function call here to PKT to the actually it will run on each packet. And this time I'm not giving it the bytes. I'm giving the offsets. The size and the actual how many things are this. No, the size of packet and the offset in the packet IO space. So you see here, the first thing I do is do a mapping here at the packet IO space at this offset with this size. The same logic for the histogram, and a bunch of assertions for inconsistency. This is very good for debugging stuff, things be in order. For example, let me see here. Offset should be okay. It's not very important stuff, but good for debugging. And 04. Here I'm giving it the new, and you see everything works. And I think it's enough. I have no time to show the DDB actually. Some very fast slide things. We have different categories like terminal input output interface, the library initialization, finalization. We have compilation and execution of Poke code. We have alignment handling. We have PVM code debugging, profiling facilities. We have declarations of types and variables. We have text support for text completion, and somebody can provide us the text completion. I didn't cover them. iSpaces, compiler PVM settings and values. And there are two things that can be improved. One is the getting rid of all global states in the libpoke, and to have more than one instance in the process, to have to enable programs libraries to use they themselves use a program that is used libpoke itself, and it will be safe using in different threads. And the other thing is we want to make Poke and C better friends. We currently don't support this call stack. If you are executing Poke code and call C codes, for example, by I/O devices or terminal interface, you cannot again, for example, PK call and go back. It is not. But we have some ideas to implement them, so you will see them very soon. And foreign functions, which is very nice. You have, for example, this C function do something, and you can declare something like this fun do something string X long, and the implementation is this statement C library, my C library. This is my suggested syntax. This is a surprise for Jose. I don't know whether he likes it or not. And it was, thanks for attending. Thanks for your interest. Okay, questions. If you have any questions, I'm here too. Thanks, Luca. Thanks, Ali. I didn't have time, but GDB stuff is very interesting. Thank you, Rick.
Yeah, there's so many things.
Mm-hmm. I think I covered most of the things, most of the useful things, but
well, it was very nice.
Welcome.
Very nice.
Thank you.
Okay, so so I guess that this is a good way to close the event, and
we have 10 minutes to discuss actually future work.
We have 10 minutes.
I think so. We don't have.
It's true. Yes, well, yeah. It's 9. Yeah.
Officially, we have time. 10 minutes.
Officially, we have until 11, until 10. Yes. So, okay, let me stop the recording at this point.